Building enterprise LLM systems requires four critical capabilities: indexing your data, retrieving relevant context, augmenting generation with that context, and fine-tuning models to your domain. This architecture shows how these components work together in production. The journey starts with advanced parsing. Your pipeline ingests domain and organizational confidential documents through source connectors, using text splitters to break content into manageable chunks. This isn't just splitting on paragraphs, it's intelligent parsing that maintains semantic coherence. Those chunks flow into document processing, where they're combined with user queries and relevant data. The system generates text chunks optimized for both storage and retrieval. This preprocessing is critical. Garbage in means garbage out, and most LLM failures trace back to poor document processing. Next comes the embedding model, typically a sentence transformer that converts text into high-dimensional vectors. These embeddings capture semantic meaning, enabling the system to understand that CEO and Chief Executive Officer are equivalent, even when the exact words don't match. The embeddings populate a vector database accelerated with Intel AVX for blazing fast similarity search. This is your knowledge base, a k-nearest neighbor index that instantly retrieves the most relevant document chunks for any query. Speed matters here because users won't wait. Now here's where RAG, or Retrieval Augmented Generation, comes alive. The system performs query neural search against the vector database, retrieves relevant document hints, and feeds them to the ML agent for context-aware processing. You're augmenting the LLM's knowledge with your specific organizational data. But before anything reaches the user, it passes through the input-output guardrail, your validation model that filters both queries and responses. It maintains an exclusion index of prohibited content, ensuring questions contain sensitive material aren't processed and responses don't leak confidential information. This is your security perimeter. The ML agent handles prompt processing, the orchestration layer that manages conversation flow. It accesses memory for stored messages in conversation history, maintains an index for quick lookups, and predicts the next action based on context. This is where multi-turn conversations become coherent narratives. For response generation, you have chat templating via the ML connector, typically calling an inference service running a VLLM server accelerated by NVIDIA GPUs. This generates the actual responses users see, grounded in your retrieved context. User feedback loops back into the system, enabling continuous improvement. The org user receives filtered responses, but their interactions inform model performance and help identify gaps in the knowledge base. On the back end, the training operator manages LLM fine-tuning, pulling models from the LLM repository and pushing improved versions back in. This is how the system adapts to your specific domain language, policies, and use cases over time. 4 color-coded data flows connect everything. Orange arrows show indexing, how documents become searchable vectors. Purple arrows trace retrieval, how queries find relevant context. Yellow arrows indicate augmented generation, how retrieved context enhances LLM outputs. And blue arrows represent fine-tuning, how the system learns from your data. The hardware acceleration is strategic. Intel AVX powers the vector database for CPU-optimized similarity search. NVIDIA GPUs accelerate the inference service for fast LLM generation. This hybrid approach balances cost and performance: CPUs for retrieval, GPUs for generation. 3 critical architectural principles. First, separation of concerns. Indexing, retrieval, generation, and fine-tuning are independent modules you can upgrade separately. Second, security by design. The guardrail isn't an afterthought, it's a core component that every query and response passes through. Third, hardware-optimized performance, using the right accelerator for each workload rather than forcing everything onto GPUs. This is production-grade RAG architecture. Not a demo, not a prototype, a system designed to handle enterprise-scale, security requirements, and continuous improvement through fine-tuning.